Hello everyone and welcome to today's TIA Portal tutorial. In the previous video we have learned how to use some of the bit logic operations in TIA Portal such as flip-flops. Today we are going to talk about other operations and how to use them. First, I want to explain what positive and negative edge means. If you look at this signal, it starts from 0, goes to high or 1, and after a while goes again to 0 or low state. A rising edge or positive edge is the low to high or 0 to 1 transition, and the falling edge or negative edge is the high to low or 1 to 0 transition. The basic of the bit logic operations in this video is these two digits 1 and 0, and they're changing. Let's start with the instruction scan operand for positive signal edge. We use this operation for detecting the change of signal state from 0 to 1. I insert it to our program. The state of this contact is true when a positive transition from 0 to 1 is detected on the assigned bit I0.0. When the positive edge is detected, the memory bit M0.0 will be on for a clock cycle. Or we can say, if you have a switch connected to I0.0, if the switch is pressed, that state goes from 0 to 1. This pressing and changing of switch will be detected by this instruction, and bit M0.0 will be on. PS scan cycle time is in range of milliseconds, and the change happens very fast and we can see it. Therefore I use set and add instruction to see and understand the output change better. So output will remain on after the first pulse. Each time by each detection the number 1 will be added to the number of pulses. You see, when I release the button, nothing happens. Again, the state is changed from 0 to 1 and contact is true. Scan operand for a negative signal edge. This instruction is like previous one, but it detects the signal change from 1 to 0. The state of this contact is true when a transition from on to off is detected. I press the button or switch and change the state to 1. Output is still 0 and we don't have yet any pulse. When I release the button and its state changes from 1 to 0, the instruction generates a pulse at its output and resets the output for a program cycle to 1. Therefore, Q0.0 is now off, and add function show the number 1. That means it has received a pulse. You see every change from 0 to 1 is detected by scan by positive edge, and change from 1 to 0 is detected by scan for negative edge. Here you can see again difference between these two instructions. First one detects change from 0 to 1 or pressing of switch, but second one detects changing 1 to 0 or releasing the switch. If I change the programming language, you can see also this instruction in function block diagram. Next instruction, set operand on positive signal edge. This instruction is used as an output. The assigned output will be true when a positive transition from 0 to 1 is detected on the power flow entering the coil. Specify operand to be set above the instruction and memory bit to save the state below it. In this example, when I0.2 or I0.3 is closed and the value here is 1, RLO here is changed from 0 to 1. In other words, it was 0 here, but when I press one of the buttons, the logic will be changed to 1, which this instruction can detect it. So the output Q 0.2 will be for a program cycle 1. It's only here 5 milliseconds, therefore we can see it. As a similar way, instruction set operand on negative signal edge detects a change from 1 to 0 in RLO. To see the change better, I have given to each set operand a set and reset output. When the RLO is changed 0 to 1, Q0.2 is true for a program cycle. This pulse makes the Q1.0 permanently true. When I release one of the buttons and 1 to 0 is detected, Q0.3 is true for a cycle time. This resets the Q1.0. This time I have released one of the buttons, but RLO here is still 1. Now RLO is changed from 1 to 0. Now I want to explain instruction scan RLO for positive signal edge. It's a little bit similar to scan operand for positive signal edge. It is used to detect the change from 0 to 1, but in the signal state of RLO. So result of last operation before this instruction will be considered. It can be an input, output of other functions, and so on. It works based on changing at its input state. For example, we have here two inputs connected in parallel. An output is given to the P trigger. P trigger will give you a pulse if one of the inputs goes too high. Or we can say P trigger will give you a pulse when one of the push buttons connected to the inputs is pressed. This instruction only needs a memory address to set it by detection. Similarly, we have scan RLO for negative signal edge, but it detects the change from 1 to 0 at its input state. When you press one of the buttons connected to the inputs, P trigger detects it and set output is true, but output for N trigger is still 0. When you release the button, signal change from 1 to 0 will be detected and output will be for program cycle 1. Let me add the add function to see this better. P trigger detects positive change and N trigger detects negative. You can see also this instruction in FBD. Instruction detect positive signal edge. This instruction compares current RLO state at clock input with the previous RLO state saved in an instance data block. Therefore, if you insert this instruction, it will ask you to insert the data block. If RLO changes from 0 to 1 at the clock input what represent positive edge, then output of the instruction will be 1 for a program cycle. Next instruction detect negative signal edge. This one is like previous instruction, but it detects change of RLO from 1 to 0. When I0.6 is pressed, the 0 to 1 is detected and Q0.5 is true. When I release the button, 1 to 0 is detected and Q0.5 is off or false. Okay, that was all of the BitLogic operations in TIA Portal. I hope this tutorial is a little bit helpful for you, and thank you for watching this video. If you have any question, please don't hesitate to write it in comments.